Then how about day 2? So let's take a look at day 2. For day 2, I have 1 unit as my demand and $4 as my cost. Okay, so it seems to me that I can get some hint about what are the amount of order quantities or production quantities that I need to consider. That again depends on my Y. So we do have that general ideas that we mentioned a few slides ago. Okay, so let's see what does that tell us. Basically, my x2 has some lower bound, which is 1 minus y plus. What does that mean? I need 1 unit. If today I have nothing, then I need to order at least 1 unit. But if today I have more than 1 unit, then my x2 can be as small as 0. That's the first part. And the second part is that I know facing for today and tomorrow, I need at most 3 units. Okay, at most 3 units. So if today I have 7 units, then I'm going to order nothing for today. Okay, there's really no reason to order. But if today I only have 1 unit, then maybe I'm going to consider order 2 units for today. If today I have 2 units, maybe I'm going to consider order or produce 1 unit for today. So collectively, if my y is 0, for example, I know for x2, I don't need to consider too many numbers. I only need to consider 1 or 2 or 3. Because if I don't order any unit, I cannot fulfill the demand for today. If I order too many, more than 3, that's not going to be optimal. Okay, so I need to consider 3 possible values for x2. I still have all those parameters, and now the table here allows us to complete the calculation. So let's see what's this. This table is saying that, okay, if x2 is 1, if I produce 1 unit in this particular period, I'm going to pay $4 as production cost. I know eventually for y1 it's going to be 0 because I produce 1 unit and then use that. I leave nothing for tomorrow. Then I have no inventory cost for this period. But because I leave nothing for tomorrow I need to pay $12 to get through tomorrow. In total, I'm going to pay $16. And what's the total thing? Is here the production cost for today, here the inventory cost for today, and the V1, the cost starting from tomorrow. Okay, and if you forget how we get 12 as V1 of 0, we go back to the previous slides. It's here. We already know that for period 1, if we have nothing at the beginning, we need to pay $12. That's how we get this 12. Okay, so that's the case if we order or produce 1 unit. What if we produce 2 units? We're going to pay more production cost for today. And because we leave 1 unit for tomorrow, we pay 1 unit of holding cost. But because we have this preparation for tomorrow, all I need to pay is $6. Why do we have that? Because 6 is here. I already know V1 of 1 is 6. So that's how I get this 6 as my cost for tomorrow. Collectively, I have 15. And if I produce 3 units for today I need to pay 12 as production cost, 2 as inventory cost, but then for tomorrow, I don't need to do anything. Turns out that this is the optimal thing to do for today. Well, if you look at the setting here, for any unit you produce for today, you pay $4. And store that for 1 day, you only pay $1. That's cheaper than $6, right? So that's why in today, your optimal decision is that you should produce 3 units to satisfy all the demands for today and tomorrow. So all the things we just did is to get this number, 14, okay? We know V2 of 0 is that we have 2 days to go. And if we have nothing at the beginning, we're going to pay $14 to satisfy all the demands for period 2 and period 1 if we do all the things optimally. So similarly, if I want to make some decisions about this case, what should I do? I'm going to calculate V2 of 1. I'm going to have 1 unit on hand. If I have 1 unit on hand at the beginning, and I know for the next 2 days I'm going to have 1 unit used and 2 units used, I know I should consider to produce up to 2 units. Okay, and I probably don't need to produce anything. So I'm going to consider if I don't produce anything, then today I'm going to, well, have a good life, but tomorrow I need to pay a lot. Or if today I pay a lot and produce a lot, tomorrow I can save cost. I'm going to pretty much repeat what I did previously for y equals 0. I'm going to be able to solve the case for y equals 1, y equals 2, y equals 3, and so on and so on and so on. Every time when I want to make a calculation for a particular initial inventory, I need to check the table or the row that I just prepared for the next day. I need to check the values for some cost that if I leave 1 unit for tomorrow, if I leave no unit for tomorrow, and so on and so on. I need to get all those numbers so that I can calculate my V2 of 1, V2 of 2, V2 of 3, and so on. So pretty much, if you know how to write a program, you should already get the idea. We're going to run it iteratively, right? We have a for loop, goes from 0 to 1 to 2. And in each loop, for example, when t is 2, we're going to run another inner loop. Y is 0, y is 1, y is 2, y is 3, and so on. We're going to fill up the table one number by one number, one row by one row. And every time when I want to make the calculation for one number, I need to probably check some values in the previous row. That's pretty much I need to do. So very quickly, if t is 3, then we do the same thing. If t is 3, initially all the numbers in the green circle are blank or question marks. I know nothing. But for example, if y is 2, if y is 2, then I want to calculate v3 of y, where y is 2 here. Then I'm going to see I probably need to consider to produce nothing or up to 3 units. Why is that? Because we know when I have 3 days, the demands are 2, 1, and 2. So if I have nothing, if I have 2 units for today, I don't need to immediately order something to fulfill today's demand. But I need to order at least 3 units to fulfill. I at most should order 3 units to fulfill all the demands for the future. Okay? Therefore, what we need to consider is that if my x3 is within 0 to 3, then I also know that for my y2, those possible values that I leave for tomorrow, is going to be between 0, 1, 2, and 3. I can decide I want to leave nothing for tomorrow. In that case, I'm going to pay $14 starting from the next day. I don't know what I'm going to do. I don't care, but I know I'm going to pay $14. If I leave only 1 unit for tomorrow, I need to pay $10 starting from tomorrow. If I leave 2 units, if I leave 3 units. I know how to solve the problems starting from the next day. And I also have the cost for today. I'm able to complete the row for t equals 3. And then finally, we can have one additional loop to solve the problems with t equals 4, and that's the end of the whole algorithm. We now know that the minimum cost to pay to fulfill all the demands given any number of initial inventory. We know if initially I have nothing, I need to pay $36. If initially I have one unit at hand, I need to pay $32, and so on. Well, that's very good. What's even better is that we actually know what to do for every period, right? For period 4, what's the reason that I can get a 20 or a 16 here? It's because when I get this value, I already know. I checked all the reasonable alternatives and I've picked the one with the minimum cost. So that's how I can get these V values. So the optimal production quantities actually may be recorded when we construct this table. That's how we solve the whole problem.